Imagine a rooftop device that transforms thin desert air into safe drinking water, powered solely by sunlight. No municipal lines, no wells, no electricity from the grid, just pure sunlight. Remarkably, it operates in humidity as low as 5%, conditions where traditional atmospheric water generators simply stop producing. The water it yields is exceptionally clean, containing zero detectable PFAS, microplastics, or lead, contaminants that independent tests found in 91% of commercial bottled water brands. These panels are already in use across 54 countries, from Navajo Nation homes lacking running water to bottling operations in the Arabian Desert. What allows this solar thermal desiccant system to succeed, where wells, rain barrels, and conventional generators fail, and at a cost ranging from $5,500 to $7,500 for a two-panel home setup, is the price worth it for the water it produces? This is what we are about to uncover. By the conclusion, you will know precisely how these panels extract moisture from the air using only solar energy, what a two-panel system generates based on independent year-long studies, and how its cost per gallon compares to tap water, wells, or premium bottled options. The analysis will move from engineering to economics and ultimately deliver an honest verdict. The concept of harvesting water from the atmosphere is not new. Desert communities like the Atacama have long used fog nets, and in 1931, French engineer Aquila Canopin constructed a massive masonry air well to condense Mediterranean moisture. 7 years later, Edmund Alton Kirsch patented a formal method for atmospheric water extraction. For nearly a century, the principles have existed. The breakthrough came from materials science. Cody Fizen, who earned a PhD in materials science from MIT and now teaches at Arizona State University, had previously commercialized the first rechargeable zinc air battery through fluidic energy. Growing up in the Sonoran Desert, he recognized that energy and water challenges are two sides of the same independence problem. In 2014, Fizen founded Zero Mass Water in Scottsdale, Arizona, filing the core patent. His critical insight was a composite desiccant, a hygroscopic salt integrated into a porous matrix, capable of absorbing moisture with the speed of a solid sorbent while retaining the water capacity of a liquid salt. When heated by solar thermal energy, the absorbed water releases as vapor and condenses within the panel. No compressor, no refrigerant, no grid connection is necessary. The first commercial panel shipped in late 2017. In 2019, Fizen won the Lamelson MIT Prize of $500,000, directing the entire sum toward deployment in the WU indigenous community of Colombia. BlackRock led a $50 million investment round in 2020. The same year, the company rebranded as Source Global, a public benefit corporation. Total investment has reached approximately $360 million, backed by Breakthrough Energy Ventures. Fizen's mission was clear: make water as decentralized as solar electricity. But is the existing water infrastructure broken enough to justify this cost? If you own property far from municipal lines, the answer begins with expense. Extending water to a remote site costs $100 to $225 per linear foot. Running lines, half a mile, can exceed $75,000 before a single drop reaches your tap. And even when infrastructure is in place, it is aging. 9.2 million lead service lines still exist in American water systems, according to the EPA's 2024 inventory, while more than 4,000 boil water advisories were issued nationwide that year. Drilling a private well is a traditional alternative but carries geological risk. Costs range from $5,000 to $20,000 depending on depth and rock type. The water may be unsafe. The U.S. Geological Survey's sampling of over 2,000 private wells revealed that 23% contained at least one contaminant above health thresholds. Another study estimated that 2.1 million Americans consume well water with arsenic above federal limits, and 43 million private well users remain outside the protections of the Safe Drinking Water Act. Bottled water appears to solve purity issues but brings hidden risks. Retail prices range from $7.50 to $12 per gallon. Yet a 2024 Columbia Rucker study found roughly 240,000 plastic particles per liter in bottled water, 90% of them nanoplastics, capable of crossing cell membranes. Producing the plastic alone consumes 17 million barrels of oil annually in the U.S. Rainwater collection can work in wet regions, but fails in the arid Southwest. Arizona, Nevada, and New Mexico receive under 10 inches of rainfall annually, and Colorado law limits residential collection to 110 gallons in 2 barrels, only for outdoor use. Conventional condensation-based atmospheric generators require what arid areas lack most: electricity and humidity. The leading home unit needs a minimum of 15 degrees Celsius and 20% relative humidity. In Southwest desert conditions, its output plummets 70 to 90% below ratings, and every liter requires grid power. All these solutions depend on something external: pipes, aquifers, rainfall, or electricity. The Hydrop panel was engineered to rely on none. Its first advantage is complete infrastructure independence. A single panel sits on the ground or rooftop, connecting to an indoor tap or refrigerator line. No trenching, no pipe network, no municipal reliance. Water never touches aging lines, avoids PFAS contamination from treatment, and is immune to boil water advisories. The source is atmospheric vapor, not decades-old piping. Second, aquifer risk is eliminated. The panel pulls air, not groundwater, removing the need to choose a drilling site or worry about dry holes. Arsenic, nitrates, and other groundwater contaminants are irrelevant. Water, starting as vapor, contains none of the dissolved solids or heavy metals typical of underground sources. Third, the phase change process ensures extreme purity. Condensing within a sealed unit, the water begins nearly free of total dissolved solids, microplastics, PFAS, or chlorine byproducts, surpassing even bottled water standards. Once condensation occurs, the panel subjects the water to ozonation for sterilization and channels it through a mineral cartridge that enriches it with calcium and magnesium. The result is drinking water fully mineralized, produced without a single plastic bottle or municipal treatment step. Fourth, these systems succeed where rainfall fails. The Sonoran Desert sees only about 7 inches of annual precipitation, rendering rainwater collection virtually useless, yet the desert air maintains 20 to 30% relative humidity. The panels continually absorb that moisture. A solar thermal absorber, reminiscent of a solar water heater, warms the desiccant to temperatures between 60 and 85 degrees Celsius. That heat raises the vapor pressure sufficiently to allow passive condensation on the cooler side of the enclosure. No refrigerant, no compressor, just pure thermodynamics powered by sunlight. The fifth principle ties the entire process together. While conventional condensation generators rely on wall outlets and consume roughly 250 watt-hours per liter, the Hydrop panels draw all desorption energy from solar heat. A small photovoltaic cell only powers the fans, control electronics, and wireless telemetry, which reports system data to the manufacturer's cloud monitoring platform. The unit operates entirely off-grid, a decisive advantage for remote or disaster-stricken locations where access to safe water is most critical. The physics is proven. The question is how real-world numbers measure up over an entire year of exposure to sunlight. The most robust independent dataset comes from technology reviewer Ben Sullins, who operated a 2-panel system in San Diego for 12 months. Over that period, the panels produced 2,539 liters, averaging about 3.5 liters per day combined, or roughly 1.75 liters per panel daily. The manufacturer advertises a peak of 5 liters per panel per day, meaning field performance reached about 1/3 of that figure. This aligns with company statements to lawmakers. In August 2024, representatives testified before New Mexico legislators that a 2-panel residential setup yields approximately 60 gallons per month in arid climates, enough for household drinking and cooking needs, but far below the 300 to 400 gallons per day a typical American home consumes. Hydrop panels are designed as a drinking water solution, not for full domestic supply. Large-scale deployments reinforce these findings. The Navajo Nation signed a $7.8 million agreement in March 2024 to outfit up to 584 homes with 3 panels each, marking the largest residential installation in the U.S. to date. In Colombia, a 156-panel array serving the Wu tribe averaged 3.2 liters per panel per day. In Australia, government-funded pilots tested 150 panels across 4 cities and the remote community of Ulamu. The harshest independent assessment came from Global Water Intelligence editor Christopher Gasson, who concluded that the panels are not the most cost-effective water source anywhere on Earth. While accurate compared to municipal or well systems, this critique misses the core advantage. In regions where traditional infrastructure does not exist, the panels provide an otherwise unavailable solution. Beyond water output, Hydrop panels prevent a measurable volume of plastic waste. A 2-panel household displaces roughly 4,300 single-use bottles annually over a 15-year lifespan. The manufacturer estimates about 51,000 bottles avoided per panel, though this assumes maximum production rather than typical field performance. Disaster resilience is harder to quantify, but equally important. Hydrop panels continued producing water in Puerto Rico after Hurricane Maria destroyed both the electrical grid and municipal supply. No fuel deliveries, no road access. Remote communities in hurricane, wildfire, or earthquake-prone areas retained access to safe water. This independence carries a value that standard payback formulas cannot capture. Laboratory tests of similar desiccant-based atmospheric water sources published by Aquaria recorded total dissolved solids of 4.54 milligrams per liter with 0 detectable PFAS, microplastics, lead, arsenic, or bacterial contamination. The water begins its journey cleaner than any municipal or bottled source independently tested. Each panel does involve environmental cost: glass, aluminum, a lithium ion phosphate battery, a photovoltaic cell, and proprietary sorbent comparable to a standard solar panel plus a small battery. This impact is meaningful but amortized across 15 years of plastic-free water production. A typical 2-panel residential system costs between $5,500 and $7,500 installed. Individual panels retail at roughly $2,950 directly from the manufacturer. Annual consumables, including air filters, a Bosch carbon cartridge, and the mineralization cartridge, total about $150 per panel. Over 15 years, 2-panel maintenance adds up to approximately $4,500, resulting in a total life cycle cost of $10,000 to $12,000. Using independent field data showing 670 gallons per year from 2 panels, the 15-year expense averages roughly $90 per gallon. In optimal conditions, manufacturer peak estimates lower that to about 83 cents per gallon. In dry or cloudy climates, where output drops, costs can exceed $2 per gallon. For comparison, municipal tap water ranges from 0.2 to 0.5 cents per gallon, making high-drop panels 225 to 450 times more expensive. Financially, the system does not pay for itself against tap water. The math requires more than 750 years. Bulk 5-gallon jugs cost around $1.22 per gallon, producing a 10 to 12-year payback. Retail single-serve bottled water at $7 per gallon reduces payback to approximately 18 months. One further note, the Federal Residential Clean Energy Credit covers solar, PV, geothermal, and batteries, but excludes atmospheric water generation. And no state-level rebates were identified for homeowners with functional municipal supply making purely financial choices. The conclusion is clear. A $35 reverse osmosis filter on your kitchen tap provides cleaner than average water at a fraction of the cost. Yet, for properties beyond municipal lines, wells testing positive for arsenic, or households experiencing water crises like Flint or Jackson, the decision shifts from financial return to resilience and sovereignty. That is a genuine and compelling reason to invest, even if it is not economically justified for most homes. Each panel weighs between 340 and 500 pounds. For residential installs, Source recommends ground mounting, reserving rooftops for commercial sites. Raising a panel onto a roof usually requires a crane and structural engineering certification, practical for warehouses, prohibitive for most private homes. Climate sets a strict limit. When temperatures reach freezing or below, the panels effectively enter dormancy. In colder regions, this can mean weeks or even months without any water production. These systems are not designed for year-round operation outside the Sun Belt. Installation options are restricted because Source relies exclusively on its own certified installation partners. Today, service is available in roughly 14 states, mostly concentrated in the South and Southwest. Before any purchase, a virtual site assessment is required, and Source can reject sites that fail to meet their standards, returning deposits. These panels are not a simple plug-and-play solution. You cannot just order and install them yourself. Legally, atmospheric water extraction sits in a gray zone rather than being outright prohibited. No state has a specific permit framework for capturing vapor from the air. Unlike rainwater, which in several Western states is regulated under prior appropriation law, atmospheric moisture has never been claimed as state-controlled water. In practice, most municipalities still expect residents to maintain a connection to public water and pay fees, regardless of usage. Hydroponic panels function as a supplementary source, not a replacement for municipal supply. Integration is narrower than some might assume. The system feeds a dedicated drinking tap, a refrigerator line, or a standalone dispenser. It does not provide whole house water. A 2-panel setup yielding 7 to 10 liters per day is sufficient for drinking and cooking, but cannot meet bathing, laundry, or irrigation needs. Solar access protections that apply to rooftop photovoltaic panels under state law do not extend to hydrop panels. Ground-mounted units weighing 340 pounds or more often trigger homeowner association objections. Site selection is crucial. Unshaded southern exposure with at least 5 peak sun hours per day is essential, the same considerations as rooftop solar. For meaningful year-round output, a practical humidity floor is around 20% relative humidity. While the manufacturer claims operation down to 5%, production at that extreme is negligible. Locations experiencing several months of freezing temperatures should adjust annual expectations proportionally. The current main product is the Source Hydropanel R3, launched in June 2023. It measures 4 by 8 feet, carries NSF 61 certification for water contact materials, NSF 58 for pressurized storage, and complies with IEC 6 1215 glass durability standards. A lithium-ion phosphate battery enables water dispensing at night without sunlight. Indoor storage tanks come in 4.8 gallons for undersink use, 20 gallons for closet mounting, and 40 gallons for higher volume applications. Installation must be performed by Source certified partners. DIY installation is unsupported and would likely void the warranty. Two grid-dependent alternatives exist for different needs. The Watergen Jenny produces up to 30 liters per day, significantly more than a hydro panel, but relies on continuous grid electricity and performs poorly in arid climates. It retails between $2,500 and $4,500. The Aquaria Hydropixel, best for humid areas with reliable electricity, is a plug-and-play countertop system priced at $3,499. Realistic output is around 10 gallons daily under moderate temperature and humidity. It was recognized by Time as one of the best inventions in 2024, ideal for suburban supplemental water where grid power is available. Avoid generic condensation units sold online in the $500 to $1,500 range. These often lack NSF certification, UV or ozone sterilization, mineralization, and replaceable filters. Output drops to near zero under dry conditions. Dehumidifier-derived water is not safe to drink, as it can contain dust, mold spores, refrigerant residues, and bacteria, regardless of marketing claims. Red flags for any atmospheric water device include missing NSF 42, 53, 58, or 61 certification, absence of third-party lab testing for PFAS, microplastics, or heavy metals, warranties shorter than 5 years, and no UV or ozone sterilization. Marketing terms like alkaline structured water or multi-level distribution should also raise concern. Hydro panels perform best as dedicated drinking water sources in locations where municipal supply is unreliable, unavailable, or contaminated, and where wells or rainwater collection are impractical due to geology or contamination risk. They are not intended for whole house supply. Once this distinction is understood, the technology addresses its niche effectively. Ideal U.S. regions include the Sun Belt, Arizona, Texas, Southern California, the Gulf Coast, Florida, and the Caribbean. Internationally, regions like the Middle East, North Africa, the Australian outback, and Pacific Islands combine high solar exposure with moderate humidity and water scarcity, making panels highly relevant. Annual maintenance involves replacing 2 air filters per panel, a polishing carbon cartridge, and a mineralization cartridge according to Source's schedule. The lithium iron phosphate battery may require 1 replacement during the projected 15-year lifespan. All services are handled by certified partners. DIY maintenance likely voids the warranty. Common operational issues include freeze damage to outdoor plumbing or tanks during unexpected sub-zero temperatures, biofilm buildup from delayed cartridge replacement, fan noise at close range, dispensing at ambient temperature, and reduced output during wildfire, smoke, heavy dust, or shading caused by new structures or trees. The Source mobile app provides real-time production tracking and fault monitoring through its cloud-connected operation center. Hydro panels solve a real problem for a narrow set of situations and perform well within that niche. For most municipal water users, they are a premium investment in reliability rather than a financial solution. For those without consistent water access, they may represent the most practical method for safe drinking water currently available. This practical distinction outweighs any marketing claims. Meanwhile, researchers at UC Berkeley have developed a device capable of drawing water from desert air using a material with over 20,000 potential molecular variations, each tunable to a specific humidity threshold. It operates solely on passive sunlight, demonstrating the potential for future advancements in atmospheric water capture. Thanks for watching. See you in the next one.